Okay, so I couldn't find a video that I really liked for this process. It's called a dihybrid cross. So di means two, and hybrid means that we're going to be doing a Punnett square of some sort. It really means that we're mixing stuff together. So you might remember these people. These are mom and dad from Lucy and Maria. Mom is heterozygous for both the OCA2 gene and the MC1R gene. So we can see from the MC1R gene that she makes the brown-black melanin, and we can see from the OCA2 gene that she makes a fair amount of it, kind of a lot of it. And then dad here is heterozygous for the OCA2 gene, so how much melanin gets made, but he's homozygous recessive for the MC1R gene, so he makes the red-orange melanin. So the first thing that we're going to want to do is put the mother's alleles on top of each column, and we're going to FOIL them like in math using the first A and the first M as our first letter. So we've got big A, big M, because they're the first ones that appear here. And then I think I screwed up. I think I said inside next. Yep. So we can put the inside letters next. So that would be little a, big M, because those are on the inside of the four. And then the outside, so the big A and the little m. And then the last letter is little a, little m. Then we're going to do the same kind of thing for the dad. So we've got his first A and first M right here. Then the inside letters, so little a, little m. Outside letters, so big A, little m again. And then the last letters, little a, little m from the last A and the last M. So that's it for setting up. The next thing that we're going to do is we're going to fill in the tables. So that means that we're going to write in the alleles for the offspring that connect each row and column. So we're going to take the mom's A and the dad's A and put them in there, and then the mom's M and the dad's M and put them in there. So there we go. We're also going to keep the A's together and keep the M's together, because that's going to make it easier to figure out the phenotype rather than having to look for where the A's and M's are. So we're going to always put the capital letters beforehand too, because these are cases of simple dominance. So our big A's and big M's are going to overpower those little A's and little M's. And then we're just going to keep going and going and going and going and going, filling in the table with all of the information that's on the top of the column and to the left of the row. Then we're going to count the genotypes of every specific type. So you can see what I've circled in red here is that big A, big M, little m happens twice in this table. So I'm going to circle it with red so I can keep track of what's going on. We can also see that big A, big M, little m happens 4 times. Big A, little m happens twice. Big A, little m happens 4 times. Little a, big M, little m happens twice. And then little a, little m happens twice also. And that's all 16. So then we're going to try to figure out the probability of each genotype. So there should be 16 possibilities. So the denominator for each fraction, if we're going to do the fraction part, should be 16 before simplifying. And of course, you should simplify just like in math if you can. So for genotype big A, big M, little m, because it appears 2 times, our fraction is going to be 2 over 16, which simplifies to 1 over 8, and that's 12.5%. We're going to do the same thing for big A, big M, little m. It appears 4 times. So the fraction is going to be 4 divided by 16, which is also the same thing as 1/4, so 25%. And we're just going to go through the whole rest of the process, say how many times it appears, what the fraction is, and the percent for all of the other genotypes here. Okay, so when we want to figure out what the phenotype of each genotype is going to be, we're going to look to see if there's a big A and a big M anywhere, because remember that these are cases of simple dominance. So if there is a big A, it's going to overpower the little a. And if there is a big M, it's going to overpower the little m. So we can see that these 2 top genotypes right here have at least one big A and at least one big M. So that means that from the M's, they're going to make the brown-black melanin, and they're going to make kind of a lot of it. So the phenotypes for both of these genotypes will be dark brown-black skin. Next, the next two genotypes both have at least one big A, but they don't have any big M's. So that means that these offspring are going to make the pheomelanin, the red orange melanin, but they're still going to make kind of a lot of it. So their phenotypes are going to be darkish red or white skin. Then we have this one right here that has little a's but one big M. So that means that this person is going to make the brown-black melanin but not make very much. So they're going to have pale brown or black skin. And then the last one is going to be no dominant traits at all for this particular person. So they're going to make the red orange melanin and not make very much of it at all. So they're going to be pale white red skin. And that's it. We got to the end. So thank you so much for sticking with me, and give it your best shot in the assignment.